In this video, I'm going to show you how to use decimal squares to model fractions and decimals. And for the purpose of this video, this large square has a value of 1 whole. So in all of these models, one large square is equal to 1 whole. So you'll notice on the left-hand side, I have the whole split into 10 equal rods. And each one of these rods right here is equal to 1/10 of the whole. So we can say that this is modeling the fraction 1/10, which is the same thing as 0 and 1/10 as a decimal. And on the right hand side, the whole is divided into 100 equal parts. So if I shade that same amount, it no longer has a name of 1/10. Its name is now 10 hundredths, or 0 and 10 hundredths, and these have the same value, so we call these equivalent fractions or equivalent decimals. So I'm now using the hundred squares for both of these models, and on the left hand side what I have drawn is 50 squares shaded in, or I could say I have 1, 2, 3, 4, 5 of the longs or rods shaded in. So I have 5/10, which is equivalent to 50 hundredths shaded in. On the left hand side, however, I only have 5 of the little squares shaded in, and each of these squares is 1/100th of the whole. So what I have shaded in is 5/100ths. So this gives you a visual representation of just what happens when we place digits in different place values. On the right hand side, the 5 is in the hundredths place. On the left hand side, the 5 is in the tenths place. This number on the left in blue, that is modeled in blue, is 10 times the size of the fraction on the right hand side. So we can also use our decimal squares to compare two decimals. So let's say on the left hand side we want to compare 6/10 to 63 hundredths. If we then shade in each decimal, we can see a visual comparison of their values. So on the left hand side I have 6/10, which means I have 6 completely shaded of these longs right here. So there's 1, 2, 3, 4, 5, 6. So I'm going to completely shade all of those in. And there's 6/10. On the right hand side, I have 6 of the longs again. I'm going to continue to shade all of that in. There's 6 of the longs. And then fill that in. But I also have 3 more of my individual little squares. So there is 63 hundredths. So we can see that 63 hundredths is greater than 6/10. And the reason for that is if we make this an equivalent decimal, this is the same thing as 60 hundredths. And obviously 63 hundredths is greater than 60 hundredths. In this model, I have 1, 2, 3, 4 complete longs or tenths shaded in. So if I'm writing this down as a decimal, I have no holes. I have 4 complete tenths shaded in, and then I also have 2 little cubes or 2 little squares left over, and those squares are each 1/100th of the whole. So I have 4/10 and 2 hundredths, otherwise known as 42 hundredths. Sometimes if you see decimal square problems, particularly on tests, they won't be drawn in the way that we would normally draw them with consecutive squares shaded in. They might have some sort of pattern, so you might see something that looks like this. When you're trying to figure out what decimal or fraction is modeled here, the easiest way is to just go through and count how many squares we have. I see 1 full long here, so that's 10 squares. Another full long right here, so that's 20 squares. In between at the top, I have 1, 2, 3, 4, 5, 6, 7, 8 right here. So I'm going to have 8 down here. So I have 10, 20 plus 2 eighths is 16. 20 plus 16 is 36 complete squares shaded in. So that means I have 3 full tenths plus 6 of the hundredths left over. So that is a total of 36 hundredths. We could even take this a step further and say on the outside, the outermost ring, I have 36 hundredths shaded in. In the next innermost ring, I have 1, 2, 3, 4, 5, 6 here. So that means 6 here. So that's 12 altogether. 13, 14, 15, 16, 17, 18, 19, 20. So the second ring, I have 20 hundredths shaded in. And then on my innermost ring, I have 4 hundredths shaded in. So altogether, we have 60 hundredths shaded in. So as a fraction, that could be 60 over 100, 6 over 10, and even in simplest form, this would be 3 over 5. So that means for every 5 squares that we have on our decimal square here, 3 of them are shaded in. We could even have a pattern that looks something like this. And if we look at this carefully, we see that for every one of my tenths here, one of my longs right here, I have 1, 2, 3, 4, 5 of them shaded in. So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 hundredths shaded in. So this would be equivalent to 50 over 100 or 5 over 10 or 1/2. Half of my decimal square or half of my whole is shaded in. So let's look at an example of how we can extend the use of decimal squares, and I'm going to connect this to these place value blocks here, which are really just three-dimensional versions of decimal squares. So what you've been seeing, the hundredth squares, are what we see on the right hand side here. So each of these flats right here are really just a three-dimensional version of the hundredth square. And it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those flats to make this large cube on the left-hand side. So if I think of the large cube on the left-hand side now as one whole, each of my pieces has a new value. We were previously using the 100 square as one whole, but now we have the large cube on the left as one whole. So as a result, our 100 square, it now takes 10 of those to make a whole. So 100 square is now has a value of 1/10, and as a decimal that would be 0 and 1/10. One of these pieces formerly had a value of 1/10, but now these longs right here, it takes 10 of the longs to make one of the flats, and then 10 of the flats to make one of the wholes. So it takes altogether 100 of these longs to make the large cube on the left-hand side. So this blue long has now a value of 1/100th, or 0 and 1/100th as a decimal. And lastly, one of these individual cubes used to have a value of 1/100th when we were thinking of the 100 square as one whole, but now it takes 100 of them to fit 100 square and plus 10 100 squares to equal one whole. So that means 100 times 10 equals 1,000. So that tiny little purple cube is 1/1000th of the whole, which is a decimal is written as 0.001. So let's now look at how we could model some fractions in decimals on the thousandths cube on the left. So the number that I have just modeled, I see on here one complete flat right in the front. And this is a little bit tricky to see, but if we look right behind this big flat, there's another flat that appears to be completely shaded in, another flat, and another flat. So in this case, I have 4 complete flats. Each of the flats was worth 1/10, so I have 4 tenths shaded in. We can compare that to this model, which now only has 4 of the longs shaded in, no complete flats. So this has no flats, no tenths, for the longs and no thousandths. So this now becomes 4 hundredths shaded in. And if we take that one more step, we can erase all of these longs right here, and we can leave this with only 4 thousandths shaded in, because there are no flats, no longs, and only 4 cubes. So we're left with only 4 thousandths.